just too many things. Okay. So, law of sines is what we were working with on Friday. And we said the law of sines is what you can do if you don't have a right triangle. Because in order to do like our SOHCAHTOA stuff, the triangle has to be right. However, on all the problems that I gave you, we were given two sides and one angle, right? Is that how pretty much? I told you you had to be given at least one angle, because if you only had sides, there were lots of possible triangles, similar triangles that could work. Now, as it turns out, we have been looking at fairly nice problems. But there are some other things to take into consideration. So, if the information we are given is two sides and an angle opposite one of them, it's possible that there could be 0, 1, or 2 triangles that exist with this given information. We've only looked at the case where there is a single triangle that works, but there are sometimes when we could have multiple triangles. So if I'm only given one angle, the problems we had before, we had 2 of the angles given to us, and we were able to just subtract from 180 to get the third. If I'm only given one angle, we have to use the inverse to get the other angles, and so it changes things. To help us decide if we can have 0, 1, or 2 triangles, we need to remember a few things. We know sine can only be things between -1 and 1. If you're in a triangle, it has to be between 0 and 1, because you're not going to have a triangle with a negative length in these scenarios. The smallest angle has to be opposite the smallest side. The largest angle is across from the largest side. And all the angles always add up to 180. So let's look at an example. Solve triangle ABC. That means find all the missing angles and all the missing sides. Side A, we know that is across from angle A, is 17.9 centimeters. Side C, so across from angle C, is 13.2 centimeters. And angle C, 75 degrees, 30 minutes. So, different from Friday because I only have one angle given to me. We can still use the law of sines. Which side angle pair do we have to use? C. And which one should I avoid at all costs right now? B, because I don't have the angle or the side. So I'm going to use the C over sine C equals A over sine A to start. So side C is 13.2 divided by the sine of 75 degrees, 30 minutes equals side A, 13.2 over the sine of angle A. Oops, 17.9. Okay. If we cross multiply, remember we try not to put anything in until the last minute so we don't have so much rounding error. What would I have to do?
Divide by 13.
Okay. So let's type this in. We need to be in degree mode. So 17.9 times the sine, 75 degrees, 30 minutes. So we do that as 75 plus 30 over 60. Divided by 13.2. We get 1.3129.
we gotta
What'd you say, Grant?
It's not possible.
Why not?
Sorry.
Yeah, can sine ever equal something bigger than 1? No. So the only way this triangle exists is if sine is equal to a 1.3. That's not possible. So there's no solution. So this is a case where there is no such triangle. And you'll find it because you'll get to some point where it's sine equals some number bigger than 1. And we can't have that.
Oh, it's, okay. I see how we would find that angle, but
Yeah.
that makes sense.
If you were needing, if it was like a 0.3, then we could find the angle by doing what on our calculator?
Inverse.
The inverse. All right.
Now it's making sense.
Let's look at the next one. Solve triangle ABC. Angle A, 61.4 degrees. Side A, 35.5 centimeters. Side B, 39.2 centimeters. So what are we going to do?
We have to do that.
We have to use A because it's the only one we have both pieces to, and the other one we would use would be B. So then we cross multiply. And then we have to divide. Type this. Keep a few decimal places right now to kind of minimize our rounding error. So this one, are we going to get an answer? Yes, this is possible. So, oh. When we do this, sine is equal to a positive. And what quadrants is sine positive? 1 and 2. This is how you can get 2 possible
I hate
triangles.
this game.
What?
There's
So
enough space
fun.
for triangle on here.
Okay. Let's get a reference angle. How do we get the reference angle?
Subtract one.
No.
No, oh, I've already done it, sorry. Sine inverse.
Sine inverse.
Oh, you shouldn't.
Would you want us to put in the whole decimal in there or just only round it?
I would do at minimum 5. You can do more if needed. And then I'll probably switch to significant digits here. How many significant digits were given in my problem?
3.
3. So I'll go to 3. So that would be 75.8 degrees. Okay. So triangle 1, triangle 2. Alright, so in triangle 1, that's like my quadrant 1, my angle could be 75.8 degrees. If we're in triangle 2, that's in quadrant 2, how would I get my angle?
Subtract my
Alright, let's finish triangle 1. We have angle A, we now have angle B, how would we get angle C? So 180 minus the 75.8 minus the 61.4, and angle C is 42.8 degrees. But I also have to get side C. How am I going to do that?
Use side A to find side B.
I'll have to go back to the law of sines. Oh, if we're going to significant digits, yeah. So then our side C, so we have A over sine A equals C over sine C. And I'm going back to use A instead of B just because A was given in the problem. The more given information we can use, the better off we'll be. So A 35.5 divided by the sine of 61.4 degrees equals side C divided by the sine of 42.8 degrees. And then what would we do? We did 180 minus both angles that we had. We had one that we were given in the beginning, and then we found angle B.
Oh.
So 35.5 over sine of 61.4 times the sine of 42.8. And side C turns out to be 27.5 centimeters. Now, check and make sure this triangle works. We know that we're in good shape because we were even able to get this far. Double check. Your smallest angle should be across from the smallest side. Biggest angle across from the biggest side. So, smallest angle was C. Was side C my smallest side? Yeah. My biggest angle was B. Is side B my biggest side? Yes. So that triangle really does exist. Okay, second triangle. Angle C. How do we get it?
Subtract or add 140 and 61.4.
And even though significant digits would say we could round that to 104, I'm going to keep 104.2 just to have, if you did round it, that's fine, because that's significant digits. But I didn't want my angle C to be off by quite so much. So that's why I kept it. So side C, we would do the same way as we did over here. So A over the sine of A equals side C over the sine of angle C, but this time that is 14.4 degrees. And that gives me 10.1 centimeters. So quick check. Angle C is the smallest angle, is side C the smallest side? Okay, angle B is the biggest angle, is side B the biggest side? Yes. So this is the problem when we do in fact have two triangles that exist. So much more fun when there's two though. All right. Let's try another one. So angle B, 68.7 degrees. Side B, 25.4 inches. Side A, 19.6 inches. So we set this up. What do we have to use? So B over sine B equals A over sine A. Side B is 25.4. The sine of 68.7 degrees equals 19.6 sine of A. Cross multiply. guys get 0.71894? So, sine is positive in 1 and 2. Reference angle, if you do sine inverse, comes out to be 45.967. If I rounded that to 3 significant digits, what would it be? So, triangle 1 is 46.0 degrees. Triangle 2
134.
Notice anything so far?
We have 2 triangles.
We have 2 triangles. Do both of them appear to work?
See, so.
Okay. Let me ask you a question about the sides that
No,
we
you
were
can't
given.
add those together.
The sides that we had, what was the bigger out of the 2?
The sides that we have now.
45.
So side B was bigger. That means angle B has to be bigger than angle A.
It's not.
But in triangle 2, this is the biggest angle.
So
Right.
triangle 2 is what?
So even if you didn't catch it now, you could catch it later. That's why when the last problem I walked through it at the end and said, okay, what's the smallest side? What's the smallest angle? They have to match. If you went ahead and found the rest of it, you will see B has a side that is bigger than A, so angle B has to be bigger than angle A. So this one over here is not possible.
I mean, it can't even add up to 180 degrees.
Yep, so you would also catch it if you went to go find angle C. If you did 180 minus the 134 minus the 68.7, you get a negative 22.7 degrees. Is that possible? No. So this time we only have one triangle that exists. Alright, so angle C, 180 minus 68.7 minus 46 gives us 65.3 degrees. And then I need side C. How am I going to get it?
Log sine.
So we could say side B divided by the sine of angle B. Well, side C over the sine of angle C. I get 24.8 inches. So we have seen the 3 possibilities. Are there questions so far? You guys think you can try one? Did we get here okay? So if you do 25.1 sine of 55 plus 40 over 60 divided by 8.94, we get 2.3 318. What does that tell us?
No solution.
Yep, sign cannot be bigger than 1. So this one did not have a solution. All right. I have a couple more. So, are you okay with stopping today and doing the last 2 tomorrow? We've looked at all 3 types. I was just going to do a little more practice. So another example of each type. But I'll go ahead and give you the homework so you can start it tomorrow. I'll do those last 2 examples, and then the remaining time you'll have to work on homework. Make sure you're doing every other odd on those.